This little thruster could be the Tesla for space travel. Yes, I know Elon Musk launched a Tesla car into space, but it won't really be able to move on its own because, well, as I learned from playing Mario Kart, the roads in space are very poorly maintained. If, like me, you'd like to drive in space like Mario and Starman, make sure you click like and subscribe. It won't actually get you off the planet, but it will get you to see more of my videos. Anyway, just like there are electric cars, there are electric thrusters for spaceships. These MIT students are testing a new way of using electric thrusters that could unlock our entire solar system.
We need to work on very different technologies for the future of spaceflight.
We're going to see if it's working.
Separation in 3, 2, 1, go.
Why do this? Rockets are an old technology. And I mean old. And while they're great for getting out of Earth's gravity well, they're not practical for going to the outer planets.
There are about 1 million large asteroids in the asteroid belt. And we visited, maybe 10 of them. So we know basically nothing.
This new breed of electric thrusters could allow us to explore deep space even sooner than you expect.
When people learn about electric propulsion, people get excited, not only because of the sci-fi aspect of it, but the development of these technologies, they are democratizing space so that more people can actually contribute.
How soon will these electric thrusters unlock our solar system? This is Hard Reset, a series about rebuilding our world from scratch. Rockets date back to about the 13th century AD, and they generally use, hopefully, highly controlled explosions to move things around. Freeman Dyson once actually proposed using nuclear bombs to propel a spaceship. Fun, right?
Early spaceflight exploration was pretty much brute force, and the only way you can get to the moon is building the biggest rocket anyone could ever dream of.
This is Gustav Peterson, a PhD student at MIT. Even though you can't really be an engineer at birth, he comes pretty close.
When I was a kid, I would sit in our basement and destroy all of my toys. I would just take them apart and try to make them better, which usually made them not work anymore. At the same time, my dad is an aerospace engineer, and I think that's what brought me here.
With the guidance of Paolo Lozano, director of the Space Propulsion Lab at MIT, Gustav has spent the past 3 years developing a new way to use electric thrusters. Specifically, these guys, electrospray thrusters.
There are many forms of electric propulsion, gridded ion thrusters and Hall effect thrusters as the real mainstay of spaceflight. But the electrospray has come up as a sort of inherently microscale technology.
Electrospray thrusters are small and energy efficient. How small? Like, you need a microscope to really see what's up.
So this is the actual thruster itself, and it's comprised of 480 individual tips in this array. And then once the thruster chip, which is this little sandwich, is fully assembled, we'll place it on a propellant tank so it has an electrical connection as well as a reserve of propellant, and then it's ready to fly.
This itty-bitty thing is the thruster and the fuel tank. Yeah, it's that small. Also, this is Mia. She's the one who's making them at the moment. So if this were Star Trek, she'd kind of be like Mr. Scotty?
I'm one of many Mr. Scotties.
So modest. This cute little thruster works by using electric fields to shoot ions out very, very quickly. Because of its size and energy requirements, it's perfect for something like a CubeSat.
And it's to the point now where it works really well, but not forever. And so the lifetime of an electrospray is quite limited.
But at the same time, the thruster head is the smallest component of the propulsion system. It's like a postage stamp size. We say, hey, why can't we bring fresh thrusters, continue the mission?
Since these thrusters don't have super long lifespans, Gustav and Professor Lozano are working on a way to stack these thrusters and use them to send CubeSats to the asteroid belt. And we're going to see one of their first tests later today.
So that you run a set of thrusters, and then when their lifetime is spent, they get ejected, and you continue the mission on the next set of thrusters. And we're going to hopefully show that we can fire all of these 3 stages and do the stage separation successfully
This mission that we're planning is called Step 1, and this mission is a 3U spacecraft that is planning to fly in 2024. What we're going to see in the laboratory today is a demonstration using the engineering model, which is pretty much identical to what we're going to use in flight.
Eventually, electrospray thrusters might have long enough lifespans to take probes anywhere in the solar system. But there's no telling how long it'll take for the technology to get to that point.
So instead of waiting for the electrospray to continue maturing, we can say, hey, let's build a stack of several of them, and we can go, say in 5 years to the asteroid belt.
By just bringing a bunch of spare thrusters, we could jump ahead to exploring the asteroid belt and beyond in as soon as a few years. You might still be unclear why electric thrusters are such a good idea. Well, look at this. This is a model of the Saturn V, still one of the most powerful rockets ever made. And this teeny tiny part at the top is the entire payload for this rocket. All the rest of this is basically just explosives that you could blow up and shoot out the back of the rocket.
The main difference between chemical and electric is the amount of propellant. And in general, a chemical rocket will use significantly more propellant. What that means is that if you have a little satellite and use a chemical rocket, most of your satellite is going to be propellant, which is not good, because what you really want to do is have a useful payload, a scientific instrument or a computer. Electric propulsion actually has the benefit of maximizing the amount of room that you have on a spacecraft, so you can use it for this useful payload as opposed to just propellant.
So with electric thrusters, you don't need nearly as much stuff to shoot out the back of your ship. You still need an energy source, but you can get that from solar panels, or maybe nuclear fission, or even fusion in the future.
We can build spacecraft that are much smaller, and therefore we can either go further or fly more missions with the same amount of money.
Sometimes we call this the democratization of space, which is basically giving access to more people to participate in this very exciting area.
In the past, it cost you at least $1 billion to make a spacecraft that went into space. If I say, hey, you can go into deep space for $1 million instead, that is a completely different avenue for exploration.
NASA's Dawn and DART missions both use electric thrusters, and many satellites orbiting the Earth do as well. And at MIT's lab, I even got to fire an electric thruster too. But they wouldn't let me go very fast.
So all we actually have to do is type whatever voltage we want to apply, maybe start with, say, 750.
Million?
No.
But even though electric thrusters work great in space, it's unlikely they'll ever be strong enough to do the job of lifting an object from the surface of the Earth up into orbit.
All right. How much force does this emit?
Like the weight of a mosquito.
Yeah, electric thrusters are super weak compared to chemical rockets. But they can work for much longer. This is one of those classic tortoise and the hare kind of situations.
Once you're in space, there's only this minuscule amount of drag slowing us down, and with only a small amount of force, you can just very carefully push your spacecraft over the duration of a really long time scale.
For example, one of the most advanced rockets ever made, a Falcon Heavy, uses all its fuel in like 10 minutes. But electric thrusters can work for months, maybe even years or longer as the technology improves. So that tiny amount of acceleration builds up over time and moves you much faster than a chemical rocket could. That's where Gustav's test comes in. Current thrusters won't get us to the asteroid belt. But if we can stack them, we can leapfrog ahead in terms of how far this technology can take us.
So we have these 3 pucks that each have thrusters on them, and we're going to mount this in a gravity offloading rig where we can release the stages without crashing into the table. What we're doing today is we're putting the whole thing together for the first time. And if this works, we're done.
Okay, whenever you're ready. We're ready for you, sir.
Well, let's get going. So this guy should be safe to plug in. Looks good on here. Yeah, first stage works.
First stage is working.
Separation in 3, 2, 1, go.
Woo! Sorry.
Second staging in 3, 2, 1, go.
Yes.
Nice. Mia, my lab mate, said that this was the happiest she's ever seen me, and we've been colleagues for 3.5 years. It's a huge weight off your shoulders when you see it finally come together.
This tech could mean that deep space probes won't be something we do every decade or so. It could quickly open the door to full exploration of the inner planets and eventually the outer planets as well. So, how will this impact our future? So picture a scenario where we can move around in space. Satellites orbiting Earth could potentially stay in orbit indefinitely with air-breathing engines. That's right, there is actually a little bit of air in space at low orbits. Not a lot, but enough to add drag that slows things like the ISS down. That tiny amount of air could be used as a propellant by electric thrusters that would allow them to keep objects in space indefinitely. And versatile options for space propulsion could allow us to make robots that clean up space debris and prevent catastrophes like the Kessler syndrome.
With electric propulsion, we can make really simple, small propulsion systems that we can add to satellites for, relatively small additional costs. And now all of a sudden, instead of having just 1,000 objects randomly going there, we can control their orbits.
But the real thing here is exploration, opening the rest of our solar system to human understanding.
With just a little bit of technology that is coming very soon, it will be possible to explore space for a university or a startup. Maybe even a small group of friends with someone who made it big on Bitcoin, right? So I think what I really want is that space exploration for the people isn't only a dream, but it's also something that you can actually actively participate in.
So if you have a bright idea, you want to explore, you want to contribute to this activity, I think that is possible. So don't leave it just as a dream. I think that the participation now is possible because of things that are happening right now in places like this.
The asteroid belt and the outer planets are vast treasure troves of knowledge that we've yet to unlock. But once this technology matures, there's something we'll be able to chart and explore for the very first time.
If we make asteroid belt exploration so cheap that it makes sense as a commercial entity to build a spacecraft to explore the asteroid belt to find resources, it will be like a gold rush.
The resources we need to build ships that can leave our solar system and carry humanity to the stars may already be in space, floating in the asteroid belt, just waiting for us to find them. These little thrusters could help us find everything we need to reach other planets and build totally new worlds from scratch.
Empire Strikes Back, when it starts, there were all these probes that come out and they start going to different destinations. That's what we want to do, but not with the dark side.
That's an important stipulation.
Yes.
Although the funding's easier, I hear, for the dark side.
Exactly.
It's a lot better funding.